Alright, let's go. Number 10. The simplest theory, and the one most physicists actually take seriously, is that a black hole leads to another point in our own universe. In 1935, Albert Einstein and physicist Nathan Rosen, working together at Princeton's Institute for Advanced Study, published a paper in Physical Review demonstrating that the mathematics of general relativity technically allow for a bridge connecting two distant points in spacetime, a structure now called an Einstein-Rosen bridge. The term wormhole was coined later, in 1957, by physicist John Wheeler at Princeton, who studied the concept extensively. In this model, a black hole is not a dead end, but an entrance, and somewhere else in the universe, potentially billions of light years away, or theoretically even in our own galactic backyard, a corresponding white hole would exist, spitting out whatever fell in. The catastrophic problem, identified through decades of follow-up mathematics, is stability. Physicist John Wheeler and colleague Robert Fuller showed in 1962 that an Einstein-Rosen bridge would pinch shut and collapse faster than any object, even one traveling at the speed of light, could ever cross it. For a wormhole to remain open long enough for anything to actually pass through, it would require a hypothetical substance called exotic matter, possessing negative energy density, something that has never been directly observed or confirmed to exist anywhere in nature. Number 9. A black hole in reverse, a white hole, may exist somewhere in the universe right now, spraying out matter that fell into a black hole on the opposite end. The mathematics of general relativity are time-symmetric, meaning Einstein's equations work equally well running forward or backward in time. Soviet physicist Igor Novikov proposed in 1964 that this symmetry implies a genuine counterpart to the black hole must theoretically exist, an object called a white hole, from which matter and light can only be violently expelled outward, and into which nothing can ever fall. If black holes and white holes are connected through Einstein-Rosen bridges, then everything crushed into a black hole on one side of the universe could theoretically erupt outward from a white hole somewhere else entirely. The problem is that white holes appear to violate the second law of thermodynamics, requiring an object of extraordinarily low entropy that becomes more disordered as it explodes outward, the exact reverse of how every observed process in physics behaves. No white hole has ever been confirmed through observation, and most physicists consider them a mathematical curiosity rather than a physically realistic object. But the equations describing them remain just as valid as the equations describing the black holes we have already directly photographed. Number 8. The moment you cross a black hole's event horizon, you may not travel anywhere at all, because a wall of pure energy incinerates you instantly. In 2012, physicists Ahmed Almheri, Donald Marolf, Joseph Polchinski, and James Sully, working at the University of California, Santa Barbara, published research in the Journal of High Energy Physics arguing that quantum mechanics and general relativity make contradictory predictions about a black hole's event horizon, a contradiction that can only be resolved if a wall of extremely high energy radiation, a firewall, exists precisely at the boundary. Their argument relies on a quantum mechanical rule called the monogamy of entanglement, which requires that information escaping a black hole through Hawking radiation cannot simultaneously remain entangled with whatever fell inside, a requirement that breaks Einstein's prediction that crossing the horizon should feel completely unremarkable. If the firewall hypothesis is correct, there is no other side to reach at all. Anything approaching a black hole would be destroyed the instant it crossed the boundary, converted instantly into radiation before ever experiencing the interior. Stephen Hawking responded in a 2014 paper suggesting event horizons might not exist in the classical sense at all, a proposal that resolved nothing. As of 2026, no consensus exists, and physicists remain formally uncertain whether crossing into a black hole means traveling somewhere, or simply ceasing to exist on contact. Number 7. The interior of a black hole may connect not to another point in our universe, but to an entirely separate dimension we have no way of directly perceiving. Theoretical physicist Lisa Randall at Harvard and Raman Sundram at Johns Hopkins proposed in a landmark 1999 paper published in Physical Review Letters that our entire universe might exist as a three-dimensional membrane, a brain, floating within a larger, higher-dimensional space called the bulk. Building on this framework, some physicists have speculated that a black hole's gravity might be powerful enough to punch a hole directly through our brain and into that higher-dimensional bulk space beyond it. This concept gained mainstream attention through the 2014 film Interstellar, whose scientific consultant, physicist Kip Thorne of Caltech, later a co-recipient of the 2017 Nobel Prize in Physics for his work on gravitational waves, published a companion book detailing the real physics behind the film's depiction of a five-dimensional tesseract existing inside a black hole. Thorne has been careful to state publicly that this specific visualization was speculative extrapolation built for the film, not a confirmed scientific prediction. Still, the underlying brane and bulk framework itself remains an active, serious area of theoretical research, and it raises a genuinely strange possibility that falling into a black hole could mean falling out of our own universe's dimensional structure entirely, into a space with rules we currently have no equations to describe. Number 6. Our entire universe, including everything you have ever seen, might already be sitting inside a black hole that exists inside a much larger universe. In 2010, physicist Nikodem Poplawski, then at Indiana University, published research in Physics Letters B, proposing a striking alternative to standard Big Bang cosmology. Poplawski's model uses a mathematical concept called torsion, an extension of general relativity that prevents the crushing collapse of matter from ever reaching a true singularity of infinite density. Instead, Poplawski argues, matter falling into a black hole would reach an extreme but finite density, then rebound outward on the other side, in an event that would look, from the inside, exactly like a Big Bang. In this model, every black hole in our universe could be giving birth to an entirely new universe on its other side, and our own universe, including our sun, our galaxy, and everything ever observed by any telescope, could itself be the interior of a black hole that formed inside a separate, larger parent universe. Poplawski has noted that this model makes a testable prediction regarding the large-scale rotational alignment of matter in our universe, inherited from the original collapsing star, though this prediction remains unconfirmed as of 2026. If correct, it would mean the Big Bang was not a beginning from nothing, but the far side of a black hole formed somewhere else entirely, a place we will never be able to see or reach. Number 5. Black holes may not simply transport matter elsewhere. They may be manufacturing entirely new, self-contained universes, one collapsing star at a time. Physicist Lee Smolin at the Perimeter Institute for Theoretical Physics proposed in his 1992 paper, and later expanded in his 1997 book, The Life of the Cosmos, a theory called Cosmological Natural Selection. Smolin argued that every black hole that forms in our universe triggers the birth of a brand new universe on its far side, complete with its own physical constants, slightly mutated from the parent universe, similar to genetic variation between generations of living organisms. Universes that happen to produce physical constants favorable to forming large numbers of stars would, over cosmic timescales, produce large numbers of black holes, and therefore large numbers of offspring universes, causing those particular physical constants to become statistically dominant throughout an ever-expanding multiverse, in a process functionally identical to Darwinian natural selection acting across entire universes instead of living organisms. Smolin's theory makes a specific testable claim that our universe's physical constants should be very close to optimal for producing black holes, a claim that remains debated but not disproven. If Smolin is correct, black holes are not simply destructive. They are the universe's reproductive organs, and our own cosmos was very likely born from a black hole that formed somewhere inside another universe entirely, one we will never observe, and one that may never even know it produced us. Number 4. At the extreme core of a black hole, physicists have proposed that gravity itself may reach a maximum limit, causing the collapsing star to bounce back outward instead of crushing to infinite density. Physicist Carlo Rovelli at Aix-Marseille University and Hal Haggard at Bard College, working within the framework of loop quantum gravity, published research in 2014 proposing an object they called a Planck star. In their model, quantum effects prevent matter from ever collapsing into a true infinitely dense singularity. Instead, once the collapsing star reaches a density comparable to the Planck scale, the smallest meaningful unit of distance in physics, quantum gravitational pressure becomes strong enough to halt the collapse entirely and force a violent rebound, transforming the black hole into a white hole from the inside out. Rovelli and Haggard calculated that this bounce could take an extraordinarily long time to become visible from outside the black hole due to the extreme time dilation near the event horizon, potentially explaining why we have never directly observed such an event, despite it potentially happening constantly throughout the universe. Under this model, some fast radio bursts, the same mysterious, powerful cosmic signals discussed extensively in modern astrophysics, have been proposed by Rovelli's team as a possible observational signature of exactly this kind kind of black hole to white hole transition finally becoming detectable from Earth after billions of years of internal delay. Number 3. Everything that falls into a black hole may never actually go anywhere at all, because the information is permanently smeared across the surface of the event horizon itself. Physicist Gerard Tufte at Utrecht University proposed in 1993, and physicist Leonard Susskind at Stanford University further developed in 1995, a concept called the Holographic Principle, arguing that all the information contained within a three-dimensional volume of space can be fully and completely encoded on its two-dimensional boundary surface. Applied to black holes, this suggests that anything falling toward the event horizon never actually reaches a deep interior at all. Instead, from the perspective of any outside observer, the information describing that object becomes smeared across the surface of the horizon itself, like a shadow printed onto a screen, preserved there in a scrambled but ultimately recoverable form, as the black hole slowly evaporates through Hawking radiation over cosmic timescales. This resolves a version of the black hole information paradox, first identified by Stephen Hawking in 1976, without requiring the object to travel anywhere at all. Under this interpretation, the question of what lies on the other side of a black hole may be based on a false premise entirely. There may be no other side, no interior journey, only a boundary surface where everything that ever fell in remains permanently, if unrecognizably, encoded forever. Number 2. General relativity itself predicts that at the very center of a black hole, space and time simply stop existing, meaning there may be no other side to reach, because the concept of a destination no longer applies. Physicist Roger Penrose proved mathematically in a landmark 1965 paper published in Physical Review Letters that under very general conditions, the collapse of a massive star must inevitably produce a singularity, a point where the curvature of spacetime becomes infinite, and the equations of general relativity simply stop producing meaningful predictions. This work, along with related theorems developed with Stephen Hawking through the late 1960s, earned Penrose a share of the 2020 Nobel Prize in Physics. At a true singularity, distance, time, and even the concept of a location cease to have any defined mathematical meaning within Einstein's framework. This means the question of what exists on the other side may not simply be unanswered. It may be fundamentally malformed, similar to asking what lies north of the North Pole. There may be no other side to travel to, not because it is hidden or inaccessible, but because the very structure of spacetime that would allow for an on the other side to exist has been crushed out of existence entirely at that exact point. Number 1. Physicists still cannot agree on any of the theories on this list, because we do not have a single working theory of quantum gravity, and until we do, the true answer may be permanently unreachable. Every theory discussed throughout this video, wormholes, white holes, firewalls, higher dimensions, baby universes, Planck stars, the holographic principle, and true singularities, depends entirely on extending either general relativity or quantum mechanics into a regime where both theories are known to break down simultaneously, a problem physicists have been attempting to solve since the 1930s without success. Attempts at unification, including string theory, developed since the 1970s by physicists including Leonard Susskind and Edward Witten, and loop quantum gravity, developed since the 1980s by physicists including Carlo Rovelli and Abhay Ashtekar, remain entirely unconfirmed by direct experimental evidence, because no experiment on Earth can currently recreate the conditions found at a black hole's core. This means every theory on this list is, at present, permanently untestable, not due to a temporary lack of better telescopes or instruments, but because the interior of a black hole is causally sealed off from the rest of the universe by its own event horizon, a boundary from which no signal, no light, and no information can ever escape to tell us which explanation, if any, is correct. Somewhere in our galaxy right now, an object is quietly consuming stars, gas, and light, folding it into a region of spacetime that may lead to another universe, another dimension, a violent rebound into a white hole, or simply nowhere at all. And every physicist working on this question today knows, with complete certainty, that we will not have a confirmed answer within any of our lifetimes. If you want to see more videos like this, click the video on screen now, and make sure to subscribe.